Welcome everyone, and thank you for joining us today on our next in the IIP Tips and Tricks series. We're going to give everyone just a few minutes to roll in and then we will get started. Alrighty, good afternoon all, and welcome to this month's IIP Tips and Tricks series, which is focused on the most common HL7 mapping errors. SIIM is thrilled to welcome back Herman Oosterwijk, an experienced professional and longtime SIIM partner who has extensive knowledge and background with implementing healthcare imaging and IT solutions. Herman is the founder of OTech, where he serves as the principal consultant, project manager, and EHR, PACS, DICOM, and IHE instructor. Ladies and gentlemen, Herman Oosterwijk.
Oh, thank you, Brad. And welcome back to the IIP Tips and Tricks. I always enjoy doing this, share some of the things that I learned. And as you probably know, most of the time I'm actually spending teaching. So most of what I learn is actually from my students. So things that they share. And so hopefully you have an opportunity later on to share some of your specific experiences and some of your of your challenges and issues as well. So common HL7 to DICOM mapping issues. You know what's kind of interesting that when I talk at IIP, there's not a lot of knowledge about HL7. I was just talking with a PACS administrator yesterday. They had some problems because the work list didn't show up. And we found out, okay, well, it looks like the modality field is empty. So I said, well, sure, why don't we take this HL7 order message, we open it in a notepad and we fill in the modality field OT and then see what happens. And of course, perfectly, the work list showed up. And then I asked, so do you ever look at HL7? He said, no, I really don't. But so what I really encourage you, and that's really very useful, remember the data, the information from the work list comes from HL7. And it's really not that hard. So this makes really an investment, a little bit of an investment to learn about HL7. Definitely takes will definitely pay off. And like I said, just this week I had that experience. So what we're going to do today, we're going to do a little bit of a refresher because I might expect maybe you don't know that much of HL7 or maybe not at all. So do a little bit of a refresher so that you can look at an HL7 message and recognize all of the information in a typical order, but it's the input to our work list. So then we'll look at the order itself, right? And then we'll talk about how the information is mapped to the DICOM modality work list. And then eventually, as you know, the DICOM modality work list is copied on your modality and then ends up in the DICOM header. And then before you know, the DICOM image comes to the PACS and then the PACS says, uh-oh. So in many cases, you can trace it all the way back, not only to the image and the work list, but to the HL7 order. So it's really useful to be able to know a little bit about it. So we'll talk about some common issues and then we have some questions and discussion. So this is an overview of the workflow. So if you look at the top, it's an information system, and the information system could be an electronic medical record, an EMR. And in some cases, not all the cases, but some cases, there will be a connection to a modality worklist provider. And in some cases, there might be a separate box, like way back, Mitra was the only game in town. But now these boxes are often incorporated in the PACS or in the RIS or in the information system or in the EMR. But anyway, there's somewhere an order. And so in many cases, there's a mapping that takes place from your order into a DICOM work list. And that's where sometimes problems occur because of this mapping might potentially not work correctly. There might be some issues, and if nothing else, you want to be able to go back and find out the source of the data. The thing I'm not going to talk about is what mapping of the HL7 results back in DICOM, because that is relatively straightforward. So if you have a result, a diagnostic report, for example, in many cases there will be an HL7 ORU message. So ORU means result. And then we would potentially map that back into a DICOM, maybe structured report or some other form. And that's relatively straightforward. I don't see a lot of problems occurring there. Basically, they know where to find the information, the text in the ORU, and map it in a text report, simple text report. Then we can then archive it on the PACS system. So we're going to focus on the beginning part, orders to DICOM worklist mapping. So let's talk a little bit about first, what is HL7 all about? Look at some messages so we know what we're talking about. So first of all, HL7 is very robust and very easy to parse. It's actually, if you spend a little bit of time learning about HL7, you will see it's really, really simple because the messages are plain text. There's a requirement, ASCII text messages. So if you look at a message, and we'll do that in a few minutes, you see the name, you see the birth date. It's all spelled out in front of you in the plain view, right? So it's relatively easy to look at these messages, and also very easy because it's text-based. Open it up in Notepad, make a change, right? And try again. So it's very robust, it's easy to parse. There's a lot of toolkits. So that a toolkit would be some, it will be a software that allow you to do parsing, to open it up, to implement HL7 interfaces. I wouldn't say it's trivial, but it's very, very easy to do. And there's a lot of experience with it, and it's extremely efficient. Extremely efficient. The messages are very, very small, very robust. And so high transaction volumes, if you think about a typical hospital, there might be literally tens of thousands of these transactions taking place every day. The other hand, though, is that there's also some disadvantages. The disadvantages with HL7, and by the way, we talk about version 2, HL7 version 2. I'm not going to talk about version 3 or 5 or whatever. So we talk about version 2, right? HL7 version 2. So the problem is there's many options. There's a lot of different dialects, a lot of different implementations, a lot of customizations, localization, additions, right? We actually have, in DICOM, we have private tags. In HL7, we have Z segments. A segment is a line in a message. So anytime you have a line that starts with a Z, you say, okay, private information. And the vendors, they charge quite a bit of money to make any changes. So that's where the interface engines comes in, where we can do our own mapping in the hospital. And I have to say that IIC, integrating the healthcare enterprise, scheduled workflow, right, profile, has made a big improvement because that spelled out what exactly would be required in the context of that particular profile to, from a HL7 perspective, what exactly would be required, what are the transactions that you will be supported, and also the content of the transactions. So look for that. If the system is compliant with the IIC scheduled workflow, that would be a big help to help you some of the interoperability issues. Okay, so an HL7 message, an HL7 transaction is typically sent from a sending to a receiving application. And then the first thing what the receiving application does, it says, why did he send that information? So the first line of the message tells you what they call the reason why. Well, they sent that information because this patient information relates to a patient that was just transferred, or was just discharged, or just admitted, or just registered, or pre-registered, or whatever they did, right? And that's just an example for patient registration. So what is critical in these HL7 messages is the event type, the event code, because each event has a code, 3-character code. For example, in A04, in the code is the code that is in the first line of the HL7 message that says, here's the bunch of patient information, and that means that this patient has to be registered, or this patient has arrived. That's actually an important one that we sometimes look for in our modality worklist provider too. Let's say we have scheduled a patient, and we probably know there's always no shows, or that people that cancel, or people come late. So we also want to look for patient arrival before we actually put something on the work list, because otherwise the technology says, where's Johnny Smith? Well, he didn't arrive yet, so why not? Why did you then put it on the work list? Oh, there was no arrival message coming. So these are the codes, right? For patient administration, there's a set of codes. There's about 64, I think. So all the way from AO1, AO2, AO3, all the way to A64. Quite a bit, actually, just for patient registration. So that's a event type. So let's go for a typical workflow, a typical encounter, and you get an idea of the kind of messages and the kind of event types that are used to manage this encounter. So, for example, a patient enters the hospital, goes to the ER, and let's say broke his arm or something. So the patient comes in and we register the patient front desk. After we register the patient, the information is entered by the administrative person there. And then after the information is entered, she or he clicks send or enter or submit or whatever it is. Then a transaction is being sent to all the systems that need to know about it with an event type A04. That means patient registration. Okay, patient goes to a little waiting room, not the waiting room, little cubicle, little cubicle. And before you know, like 15 minutes later, a nurse comes in and the nurse says, okay, oh, that doesn't look good because you might have an open fracture, right, on the arm. We need to have a planned encounter. Okay, and so the nurse goes back to the computer, put some information in the computer keyboard, enter A05. Okay, 10 minutes later, doctor comes in, says, no, the nurse was correct. That doesn't really look good. You need to have some surgery done because I need to set this arm for you. So I'll have to a nurse admit this patient. Enter information, A01. Okay, and then 10 minutes later, a transport person comes in. Okay, we need to bring you to the OR. Okay, get ready, enter the information, transfer, but then the ambulance comes in. More urgent case, okay, hold on a second, cancel, transfer. Finally, after half an hour, we transfer you, we set the arm, and we discharge. So this is 1, 2, 3, 4, 5, 6, 7 messages just with regard to patient administration. After the patient came in, right, the patient came in and was in a little cubicle. It had quite a bit of pain. So the nurse said, you have a lot of pain, so let me give you some painkiller. So what do? Order IV with medication right here. And then before surgery, we order, I don't know, whatever it is, shoot your kid, right? All that kind of stuff. So in the meantime, we probably have a couple of orders. And then in addition to that, there's observations, there's notes. So before you know, you have 20, 30, 40, 50 messages of one patient encounter. How many encounters do we have? 100, then 50 is 5,000 messages. Just the ER. How many messages do we have for the inpatient? So you can see that it really adds up. Tens of thousands of transactions on a day is not unknown, is not unheard of. So typical workflow is this. So now let's look at some of these messages. So here's a typical patient registration message. Right, we said that each patient registration message needs to have an event type. So the ADT is A01. ADT01 is right here on the top. And when you look at these messages, you see the different lines. And they always start with the 3-character code, MSH, EVN, PID, PV1, OBX, AL1. And it's supposed to be one line. So a segment is a line of information that groups together. MSH, message header, all you need to know about the message from mega registration system to the image order system, right? It's an ADT AS1. What patient does it go? PID, patient identification. This is a patient registration for Barry. And you can actually look at it. M probably needs mail, right? And Birmingham, Alabama, this probably is address, right? So it's very easy to read, to see the information. And if you want to know the doctors, PV1 visit information, Dr. Rex Morgan, then we Dr. Lucy, right? MDs, all the information right here. And if you want to know the weight, 79 kilograms. It couldn't be more descriptive. The height, 1.8 meters. Couldn't be more descriptive. So you see how easy it is to find information in these messages. And it's relatively easy to make changes in the messages because they're ASCII text. Open a notepad, make changes. Of course, you need to know a little bit what you're doing. One of the things what you could do, this is what we call a production message. It is identified with a character P in the MSH. You could actually change P to T, which makes it a test message, and do some verification, right? So that means if you have a T, that means that the receiving system knows, okay, by the way, this is just a test message. I don't need to look for this particular patient. So simple. And by the way, the encoding itself, right? So every component has a fixed location in the HL7 message. It's like a form in a fixed location. For example, the patient name, Barry, is always at the 1, 2, 3, 4, 5th location. And the location is identified with these pipes, with these bars. So you count the bars. And that's actually how we specify interfaces. If you look at an interface spec, for example, of your modality worklist provider, it says, okay, the patient name, DICOM 1010. Where does it come from? PID, PID, dot 5, PID 5. Where did the patient sex come from? PID 6, 7, 8, PID 8. See, right here. But the patient, the birth date, PID 5, 6, 7, 7, PID 7. So that's how we specify the mapping. Right, so simple, right? ASCII text based, and you see how compact it is. And so that's why we can, have tens of thousands, literally, of these small messages going back and forth through the hospital. Sometimes we group these messages together. We call it batch mode, right? For example, at the end of the day, we might send a list of all the orders for supplies and PPP and whatever we need back to a big provider, maybe McKesson or somebody else. So we put all of these messages together in one big envelope, so to speak, as a batch header and a batch. So we take this exactly like it is. We put a little batch header before it, and then we might have 100 orders, and it's being sent over in a batch mode to the receiver, the provider that will actually provide the materials. So it's relatively simple. So okay, so that was patient registration. So now what we're really looking for is an order, because remember the patient registration messages, you don't necessarily see a lot in the packs, except for the fact that maybe a patient arrival. That will be the only thing that you're looking for. Typically, I don't care so much about patient registration. What I typically worry about is the radiology orders, right? Or cardiology orders, or imaging orders, right? Anything that has to do with imaging. Okay, so in IIT, remember the scheduled workflow profile that says the order management, you should have an order message, and then with the tracker event 001. And in the order message, it has a control code that says this is a new order, canceled order, continuation order, stop order. So it's an order control code, right? Now, there are two concepts when you talk about orders. First of all, there's the order placer. What is the order placer? Well, that could be the electronic medical record, right? The EMR, or let's say there's a CPOE, Centralized Physician Order Entry System, CPOE. So EMR or CPOE system, that's where a doctor goes and he says, okay, I need to order lab, radiology, and pharmacy. 3 different orders, 3 different placer order numbers. Okay, then we get, let's say we're here in radiology or cardiology, and this order comes in the modality worklist provider. And what the radiology or the department then does, they assign a order filler number. These are important concepts, order placer and order filler number, because in HL7, we don't necessarily talk about accession numbers, what we do in radiology and cardiology. An accession number is the unique number that is assigned to an order. But so in HL7, we call it an order filler number. So if you ever want to look for an accession number in the message definition, look for the order filler number. That's where typically the accession number is filled in by the order filler, the department. Okay, let's go look at an order. So here's a typical order. Remember, we have an MSH. MSH is the first line that tells you from where. So again, from mega order, University of Alabama, and we send it to the image scheduler at the imaging center, right? And it's an ORM 001. Oh, cool. ORM 001 means an order message. What kind of an order message is it? There are 2 components. There's the OSC and the OBR. It's a NW new order. New order. I'd like to also highlight this one. See, patient visit. Patient visit. This is actually the patient class, I. Any idea what it might mean? Inpatient. Why is it critically important? Let's say we have two CT scanners, one inpatient, one in the radiology, and one in the outpatient clinic. If I want to schedule a procedure, how would the modality worklist provider know? Is it for the radiology or for the outpatient clinic? Well, this class, this I, inpatient, would determine that. So that's one of the mappings that we typically look at PV1I, said, okay, if an inpatient, it's going to be for radiology, a very important parameter. Sometimes it's kind of cool, you know, these HL7 messages are kind of a little bit puzzles. You have to find out what could indicate, what's the information that can indicate what modality it should be performed on, because there's no such thing, as we look in a few minutes, there's no such thing as a modality in these messages. It doesn't say anywhere it's CT, MRI. Right? You have to figure it out based on the procedure code. Yeah. Okay, so let's go look. So we remember we have an MSH, PID, PV1, and then we have an OSC, common order, and OBR. Let's look at the details a little bit over the OSC and OBR, because that provides all the information that is mapped into the DICOM worklist. OSC, common order. Again, it's a new order, and WOC, order control code, OSC number 1, so order control code. And remember we talked about placer and file order number? That's right here, placer number, order number. So we see a placer order number, it's the U123456. There's no file order number. This is sent to the department. So the department has not filled in that accession number yet. So they're still empty. What else is important? Entering organization, ordering provider, callback phone number, and so on. The details are really in the OBR, the next line. So in this case, we have here again repeat the place order number, filler order number, right here, place order number, filler order number, right? OBR 2 and 3. And then here's important. Procedure code is in the Universal Service ID. Universal Service ID. So what we see here, we see it's a 93T, is an order for the 93,000. That means electrocardiogram defined by CPT4 procedure code system. Yeah? That information is mapped in the worklist. So now this goes to cardiology, they know they have to do an ECG, a 93,000 ECG defined in the Universal Service ID, OBR4. Remember that OBR4, because you know, if somebody mapping issues always have to do with not the right procedure code, or they take the abbreviation instead of the real description, and so on. I've seen, you know, I have spent quite a bit of time looking at these OBR4s. What else is important? Oh, here, transportation mode. Well, we need to know whether we need to catch somebody, or whether the patient is going to be WALK, walking in, wheelchair, WHLC. There's actually an HL7 table defined that gives the abbreviation for somebody who's walking, wheelchair, stretcher, and things like that. So that we know how to get the patient. Is the patient going to walk in, or do we need to get him if it's an inpatient, send somebody to the department, to the floor? Very important reason for study. That's also mapped in the worklist, because if you have a chest X-ray and the chest X-ray is taken and you give it to a radiologist, and the radiologist looks at the image and he says, why is this X-ray taken? What was the reason for the study? Was it coming out of a motor vehicle accident? Is it a COVID, suspected COVID case? Is it whatever it is, right? Reason for study. Very important information has been mapped. Okay, so what we did now so far is we looked at the HL7 messages. So we get a little bit idea of the information that is in these ordered messages. Now we need to map it in my worklist provider to a DICOM query response. And how does that work? Well, it actually took a specification. You should, in your hospital, there should be somewhere a specification of your modality worklist provider that tells you from HL7A to DICOM B. So I took just a arbitrary specification, and actually from a company that doesn't exist anymore, or old PAX company that is still at the spec that they use in their training classes. So here's a typical example of a HL7 to DICOM mapping. So now we understand everything that's in there, because hopefully, supposedly, we're somewhat familiar on the DICOM side, right? The DICOM side, where we have the data elements, right? The data elements on the right side. Whoops. The right side. So, for example, the patient ID is 1020, right? Patient name is 1010. Verb date is 1030. So these are the tags that are mapped or filled in our work list, and then later on end up in our DICOM header. And what is now the source of that information? Okay, now remember PID 7, PID 7. See, it tells you I map in PID 7, but that's the value type TS timestamp into my date of birth time. It is DICOM 1030, right? With the data type DA and the time in the data type TM. Why is these data types so important? I'll show you in a minute. TS defines exactly the format of how it is formatted. And unfortunately, these HL7 people and the DICOM people, they talk together. I was actually part of a committee. It's called the HL7 DICOM Integration Working Group. But initially, they really didn't talk. So they come up with data type definitions and formatting that is usually 90% of the time the same, but 10% of the time it's different. So they different data type or a different format for the name and for the date. So that means we need to do some conversion. And if that's not done correctly, then eventually we might end up again at the PAX side. It says, invalid value in field. And we'll come there. What is that reason again? Because in many cases, it's just that it was completely legal in HL7, but the modality worklist provider, for whatever reason, did not do the right conversion into the data format DICOM. So there's HL7 speak and DICOM speak, right? And you need to convert it. It needs to be an interpreter almost, like you have an interpreter in between that can talk between HL7 and DICOM. Excuse me. A sip of water. So remember, we had the patient ID, we had the patient name, we have the birth date, patient sex, PID 8, see, PID 8, PID 8. When it says AIS, that actually means it comes from a table defined by HL7, similar to when it says CS code sequence in DICOM. It's also from a table or list of predefined values. Okay, we have the address, account number, citizenship, military status, referring doctor. Very important as well. Actually, PV18, referring physician, in 890 in a work list actually is a required attribute in the DICOM header. If it's not there, it should be there. Excuse me, it always should be there 890. So here's an example. This was only one page. There's more information that is mapped. The procedure code is mapped. Okay, I guess, yeah, this will be on the next page. Yeah. Right. So we have remember the Universal Service ID in OBR4. Universal Service ID, OBR4. Right? That's the procedure code. And now do we map that? Right? Procedure code value, like this one, the 93,000, the meaning, EKG, the coding scheme, CPT4. Right? Okay, so we have ambulatory status, TP indicator, specimen source. And then there's some other information here. Here's where the CC segment. So we look at this. We're still on the OBR. We're still on the OBR. Right? So we have OBR segment, and then we have the schedule procedure step sequence. My modality. Right? Modality can come in here. So sometimes the modality is available. It's interesting. It's actually OBR 24. I was looking at a message yesterday with one of the PAX administrators. Actually, they put it in OBR 21. So you see, every hospital is a little bit different. This PAX put it in OBR 24. That one was in OBR expected at 21, and it was not filled in. They had to fill it in there. Right? And very important, this study instance UID. Study instance UID. Sometimes it is provided as part of the HL7 order. It's called the ZDS because the original, remember what Z again? Z segment means extension to the HL7. In the original specification, HL7 people didn't have any clue about study instance UIDs. There was a typical concept in DICOM, so they created as part of the IHC specification a special line called ZDS, and that's where the study instance UID is filled in and then will be mapped into a work list. Because remember, the study instance UID is created by the modality work list provider. Series and sub-instance UID is created by the modality. Study instance UID created by the modality work list provider. Okay, so this is a typical HL7 to DICOM map. So we looked at HL7 message, we found out all the data in there. We say now it goes into DICOM. And now the next part of my presentation says, okay, what can go wrong? What are some of the issues? What are some of the problems? Okay, so let's go talk about a couple of ones. And the first issue will be a length mismatch. So remember I said, when you look at these mapping, there's a data type definition on the left. HL7 there's a data type definition on the right, which is DICOM. So let's take, for example, the patient name. Patient name in HL7 is very well defined. And we actually, the data type is called XPN, extended person name. And how many components do we have? 14. Wow, 14 subcomponents. Right? And so, for example, so we have the last name, given name, second name, given names, and so on, right? How long can it be maximum if you fill in everything? 1,103 characters. Wow, that's pretty long. Okay, so anyway, so we go to the DICOM standard where the person name, right, is the mapping from XPN, right? The mapping from XPN, to a person name, PN, person. So if you look at a, if you look at a DICOM specification of the in the data dictionary of the PN definition, it says PN is a person name, and how many components do we have? 5. 5 components. Okay. 14, 5. All right. So one of the things that the modality work list provider has to do is strip off everything that is 6 and higher for sure, because otherwise somebody in the PAC system will, some system in the PAC system will say, okay, too many components, I don't have any place to put it, illegal, go to the lost and found file, and who needs to fix it? The IIP people right there. Okay, so 5 components, how long? 64. Now, I would actually argue that it's relatively uncommon that you probably have a name that's more than 64, relatively uncommon, but it could happen. But what I want to indicate is that this is one typical example, right? There's a mapping, all of the attributes have a mapping. It's just one example, but it is almost like a coincidence if the length in HL7 would be exactly the same as in DICOM. Right? So make sure, so it's not uncommon that at the PACs that sometimes you might get like, I don't know, an institution ID or some other name. And we just have too many characters. So make sure that the mapping is consistent with the length limitations. So that's number 1, length mismatch. Number 2, formatting. So we just talked about formatting. And again, it's not, this is kind of a not really dramatic difference, but just look at the name, right? So name, family name, given name, right? Suffix, prefix. You see that? Suffix, prefix. In DICOM, it says prefix, suffix. So the doctor so-and-so, MD is exactly reversed. Big deal. I mean, and the PAC's is not going to break down on it, but again, a good example where there are nuance differences that has to be taken care of in the mapping. And again, I just took the name as an example, but there will definitely be others, right? So make sure that, so you actually need to have the book in the hand. Actually, you have I don't know if you're familiar with it. Oh. I have this little DICOM reference guide that I created one time. And I guess all the tables of all the different attributes and all the different value representation, I use it all the time because I have to find out, okay, are there any mismatches in lengths and in definitions, right? Okay, cool. So formatting mismatch. What else do we have? Well, we have some mapping issues, and that has to do with, remember, sometimes there are tables that have predefined values in HL7 and in DICOM. And again, I just took an arbitrary one that I just happen to be familiar with. So let me look at the patient sex, right? In HL7 2.1, there are 4 values, F, M, O, U. In HL7 2.7, remember the different versions in HL7, 2.3, 2.4, 2.5. You might have 2.3, 2.3.1, 2.7. There's actually all the way up to 2.9. You very likely have probably 2.3.1 or 2.5. But anyway, so how many options? A, F, M, N, O, U. What does DICOM expect? Male, female, order. That's it. Is there anything, at least as of now, that is defined as a sex identification in the DICOM header? So again, so if I, for whatever reason, it would be straight over and would be out something like not applicable or whatever, ambiguous, comes in the DICOM header, I would I would very likely, PACS would complain about it, said not FMO, illegal image. And then he said, how did this A came ever in here? Go back to the work list, go back to the HL7. Yeah, of course, it's perfectly okay to put A in there because it's an allowed value according to HL7 2.7 in these messages. So it has to be mapped correctly and mapped to an O, for example. So tables, content mismatch. There's also what we call, I call the location mismatch. And patient ID is notorious for that. Right? Because patient IDs, and actually there was a question, one of the people that registered for this the particular tricks and tips said, so how do I deal with MPIs? So there's a lot of patient IDs. There's a master patient index, MPI, there's a medical record number, there's a social security number, there's an internal ID, there's an external ID. So particularly in the United States, we're kind of chaotic. I mean, we brought it upon ourselves basically, because as you can hear from my accent, I came originally from Europe. And so when I go back home, well, I wouldn't say back home, I back to where my sister and my brother still live, they have their own card, patient ID card. They go to the hospital and it's a patient card and they have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 number. And nobody has any question about patient ID. But we just have to deal with, here you come to a hospital and they give you an internal ID and another hospital has another ID. So that's why we have this whole patient identification, cross-referencing and IHC, so it's kind of chaotic. But anyway, so the HL7 methods can have different IDs, internal ID, external ID, master patient index, medical record number, in different locations. Yeah. So for example, in the patient, so in version 2.1, we have an external ID, we have an internal ID, we have an alternate patient ID, and so on. So what happened after 2.3.1, right? He said, you know, why don't we just take all of those and put them in one attribute called patient identifier list. And we tell them who's the issuer of the patient ID. So a big list, and you can go there. But now if my receiving system is in 2.1 or 2.2 and looks at PIT 2, it will be empty. It doesn't know that, okay, now suddenly it's supposed to be in PIT 3. So we cannot find it. Yeah. So patient IDs, notoriously always a problem. Could be different locations. Most after 2.3.1, this is kind of the most implementations. It's very likely in the patient identifier list, but then still, even it's a list, do we get the first of the list, the second of the list, the third of the list, the fourth, whatever it is, right? Is my medical record number, my IPI, fourth or the fifth? Definitely some mapping issues right there, right? Okay, so different locations. Stuff can be in different places. Now we have the coding, right? So typically for procedures, we have CPT, procedure codes, CPT4 codes. But it's not uncommon because when you use a procedure code, CPT4, how does the ordering system know what the code is for an EKG? Well, it uploaded from a code table that are licensed from the American Medical Association, AMA, that manages these CPT4 codes. And so So, for example, when a physician then selects EKG, internally would know it's a 93,000. Right? But imagine for that reason, you have a small practice management system, and they didn't pay the licensing fees for the AMA, and so they have their own internal code system. So there might be 1, 2, 3, 4, 5. Who knows what number they use? If I, at your modality worklist provider expect the CPT code, we might have to do some mapping there. Right? So procedure codes are extremely important. Why? Because we do, again, the earlier example, we schedule for a CT head with or without contrast. I don't know what the number is. Some of you maybe have a CT background, you probably know it by heart, but let's say it's, I don't know, 80,000 or something. So that would then determine that it is a modality CT, so it has to be on the CT work list, right? The EKG 93,000 will determine that it will be on the work list for the EKG equipment in cardiology. So it's very important to make sure that we have the right code. So coding systems, I see quite a bit of issues right there. Okay, so that's more, what in my perspective, some of the most common mapping issues, and there's some other issues. I call it miscellaneous. You have to be aware of user entry errors. So let's say somebody enters the patient name, Herman Osterwijk, in the last name field. So it will be the last name starts with an H because Herman Osterwijk is in the last name field. And that's actually one of the one of the relatively common frustrations that when I talk with some of my students that are PACS administrators, and they ask me the questions of, what can I do? Because these are the people that clean up the mess, so to speak. So what can I do about the front desk being lousy and not being accurate enough, and sometimes putting the name in the wrong field? What can I do about it? I said, I don't know what you can do about it. You have to talk with your supervisor. So anything that is depending on user entry could potentially have errors and problems. And last name, first name is one of the common ones. Another miscellaneous issue is that some of the worklist providers are limited, right? And so typically at a modality, each modality has different requirements for what they want to see. Of course, some of the pregnancy status for X-ray, contrast allergies for anything that has to do with contrast. Sometimes they want to know the last menstrual date, whatever the information. Weight is very important. If you have somebody that's really overweight, more than 400 kilograms, no, 400 pounds, 400 kilograms would be a lot. More than 400 pounds, maybe the MRI table would not be able to carry that weight. So weight and things like that. So some of the information is really important, and depending on the modality, what is important. And guess what? Maybe your work list doesn't have a place for that. Maybe there's no place for LMD or weight or something like that. So you can use creatively. Many times, almost always, there's a patient comment field. So use the patient comment field, and you put in, for example, the weight in, right? So allergies and stuff like that. But one of the things that I also see quite a bit is that PHI, personal health information, right? That is HIPAA, subject to HIPAA regulations. I see sometimes PHI showing up in series descriptions, study descriptions, comment fields. No, that's a no-no. Be really, really, really careful with that. Do not ever do that. Why? Because let's say we want to submit this image to a clinical trial, or we want to submit it to an AI algorithm in the cloud. And before we do that, no problem. We anonymize all of the information. We take out the patient name, but in a comment field, still the patient name. I've seen that like a few weeks ago or so in a series description. They put in this hospital, they put the name / CT head with without contrast. No. Make sure that you don't do that, because down the line, and this case was a particular case, what I'm talking about was for clinical trial. So then somebody has to just try to clean it up. Okay, so this is some miscellaneous issues. Now, how would you troubleshoot it? What are some of the tricks that are related to the troubleshooting? How are we troubleshooting it? So we have a problem, right? With the mapping. Somebody shows up and the image shows up rejected. He said, okay, oh, that's interesting. Let's look at the header. Oh, Now let's go back to the work list, and then we find out the order that belongs to that. So we find the HL7 order. And so, you know what, I'm going to see what the problem is. I'm going to change the order and see whether the problem would disappear. Very easy, very easy. You can use an HL7 editor, right? Or a notepad. Notepad, everybody has notepad, but if you go to online, you can actually go, one of the things that I like is a smart HL7, smart HL7. So if you Google for that, it's free. You can load an HL7 message in there, you can look at it. So go use an HL7 editor, use notepad, change suspicious field, and you resend it again, right? And then use, remember the one that was in MSH, there was a field called production type. So change that to from P, production, well, that was actually called processing type, right? Production to training or debugging, right? So you can do that. So another way, if you have a problem with HL7 methods and you think, and you really cannot figure out exactly what the problem is, there are HL7 validators, like there's also DICOM validators. You know, you have a problem with an image, you can run it through the validator and it says, okay, line 6 is too long, or has an incomplete value or an incorrect value, or line 7 is supposed to be there, it's missing. I look at quite a bit of DICOM headers, but I don't know what's supposed to be in every header of every modality. So I just use a validator quite a bit for DICOM. There's also an HL7 validator. It's called messaging workbench, MWB, great tool, excellent tool, developed by the VA, I think in Rochester or Syracuse, somewhere in upstate New York, the VA. So Peter Ronti, and actually he developed this very sophisticated, nice messaging workbench. You upload, you can actually define a message definition, and you can actually test against it. So very, very useful. And actually we use it quite a bit when we do the IIC connectathons. Remember, schedule workflow profiles and IIC profile. So once a year we go to do this connectathon thing, and then we connect all these systems together, see whether it works. And messaging workbench will be used to validate the messages that are created by these order entry systems to make sure that everything is correct. And then last but not least, you should really know how to map HL7 into DICOM in your modality worklist provider. Right? You shouldn't have to call the vendor every time. Can you map? Can you change? Can you do this and this? Right? It is not that hard. Typically, it's typical user interface says from PIT 5 to whatever the field is, or from PIT 2 instead of PIT 2 the patient ID, from PIT 3 the second line item in that list to the patient ID field. So it's really worthwhile to know how to do this mapping yourself. So you don't always have to call the vendor, because every time you have a new modality, you might need to do some mapping, right? Because that modality might require, information in certain fields as well. Or anytime you have a new version of the HL7 interface that comes along with a new upgrade of your EMR or your information system. So I really strongly recommend learn how to map HL7 into DICOM. And if nothing else, start out with getting the specification. The earlier slides that I showed you before, it was exactly the same specification as you would find in your mapping specifications. Left HL7, right DICOM, and that's with the mapping. And so if there's something go wrong, you can say, okay, let's look how this mapping is supposed to happening. Okay? So very, very useful. Actually, I think some of the vendors actually offer courses in this mapping. It's not really definitely rocket science. So where are we right now? We're almost finished. So and summarized. So the DICOM header contains information that was originated from a HL7 order and partly entered by the user. Right? So if they have a problem with the header, it's being rejected, unverified, broken study, you need to be able to go back all the way from the DICOM header to the work list, to the order, and sometimes to the user, but it's the data entry person. So we can have user entry person, right? We have mapping issues, right? We can cause data integrity issues. Data integrity, for example, information is not there, it's too long, incorrect, right? and I will reject downstream other packs. Now, the problem sometimes is that, let's say we have a very, I call it liberal packs. Liberal packs is I don't care whether the patient name is more than 64. I don't care whether the institution ID is more than whatever, 36. And I don't care. I just store them in a database anyway, and because we know that some people are not quite following the standard. So we have a very liberal packs, assuming, and then we have a very picky VNA. So we send it from them to the VNA, and then the VNA says, "Oh, that's not good. That's not valid. There's something in there that is too long. It's incorrect, right?" So even although it's be accepted by the packs, or you're going to get a new packs, and you do data migration. Right? That's where these things kind of typically break up. Data migration could be like 2 or 3% of the images don't make it from the old to the new packs. Why? Because of these issues that are sometimes related back to HL7 mismatching with DICOM. So downstream is very, very important to look at it as well. So you want to know the cause of the most common issues. You want to find where the spot the problem areas are, and not that many. So we looked at these HL7 messages. There's probably only a handful. What do you look for? Accession number, procedure code, patient ID, patient name, maybe less than 10 that always give problems. So you don't necessarily have to be able to understand everything. But if you know where to find those 10 important critical attributes, referring physician, right? A reason for study, and then, patient weight. If you know about the 10 or 15, you can, and we have access to the interface specification, you know exactly what to do if there's a problem, right? Okay, so that was kind of in my conclusion. I wanted to take some time for you to answer some questions or share some experience. What is the thing that you've seen? What are the things that you want to share with the other audience? Say, oh, I got this problem. I got this problem that I didn't really mention before. And by the way, but you just want one more thing. So resources, of course, the HL7 website where you can find access to the standard and all the definitions. But there's a very interesting resource as well. So I'm not related at all to this company called Characteristics, but Characteristics is a healthcare IT company. And they really provided a great job, because if you type in, for example, HL7 ORM or something, Characteristics will show up, and they have all the complete standards online. So I never go to the HL7 standard anymore itself, because it's many, many different parts and what section, what page. I go to Characteristics and I want to find a table, and that's what I did. For example, I want to find the table that have transport mode, right? What are the abbreviations for transport mode? What's the abbreviations for patient race and things like that? Excellent website, excellent website. And so, of course, my contact information to stay in touch. But okay, so back to you, Bradley. So do you have any questions from the audience?
We do, and thank you again, Herman. That was an awesome presentation.
Thank you.
So we have a two-part question here. Are there any open source MWL orchestrators available out there? And are interface engines capable of generating an MWL?
Yeah, so yes and yes. Actually what I use a modality worklist provider that is by Conquest, CONQUEST. Of course, it's my favorite pack because it's developed by the NCI, National Cancer Institute in Amsterdam in the Netherlands. But it's very, very, very useful. It's a limited modality worklist provider. As a matter of fact, I was using it again this week earlier to test exactly one of the new devices, and they couldn't get it to work. So it's a modality worklist provider, somewhat limited. Conquest, it installs in literally a minute. Yeah, and what you can do, you have an HL7 order. You can drag it over into that window, and then it will be added to the database. And then you can do an internal query in Conquest. You can do modality worklist query internal to make sure it works. And then externally, you can actually query that provider too. So that's the one that I use the most because it's so easy to use. You can drag orders in there. One that is a little bit more complex and a little bit harder to install is the DCM4CHE, right? So DCM4CHE, it's a kind of a sophisticated, big open source pack system, but a very nice worklist provider. As a matter of fact, I know some people that use it actually in a kind of semi-production environment or as a test packs or something. So if I want to do really some more sophisticated testing, I use the DCM4CHE modality worklist provider. And what was the second question?
Are interface engines capable of generating an MWL?
Yeah, most of them will. If you go to the new version of MRF, right, they will provide it, I think, but it's very limited though. I'm not quite trusting these interface engines because these are HL7 people and their implementation are relatively immature, so to speak. But I think even CorePoint has some limited implementations. Orion has one. So interface engines do provide modality workless implementation. I would not, what I've seen are relatively limited. I would not necessarily trust them. And, but you can try it on MRF. I haven't really tried MRF myself because I like, Conquest is just what I need to do. And then MRF I use for an HL7 interface engine. Okay. Any other questions?
Awesome. Yeah. So we maintain the social security number, an internal patient ID, and an MPI. Where are those mapped in the DICOM work list?
Oh, yeah, that's a good question. So HL7 is the good news is it's very flexible and very extensive. We have an internal ID, an external ID, an MPI, and social security, and we can put all of that in the HL7 messages, right? The only problem is sometimes where to find it. Is it in the PIT 2, in the PIT 4? Is it in a list after 2.3.1? Right, version 2.3.1, we put it all in a list in PIT 3. But anyway, so it's very flexible, very extensive. So assuming we can find it, right? Okay, now we need to do the mapping. Now, DICOM is somewhat limited. But actually, the patient ID is kind of important because it's a unique key in the database. So one of the decisions you have to make when you install a new system says, what are we going to use as the unique patient ID in my PACS system? Is it MPI? Is it the medical record number? No, we're getting away from the social security number. We don't want to, because it has too many tangents and potential connections to other personal or private information, right? So there are two locations. It's called the patient ID, patient ID. And there's an other field called other patient IDs. So the idea is that whatever is the primary patient ID, which is the unique key that we use in the PACS system, and whether it's a medical record number or whatever, you put that into the patient ID field, the primary patient ID. And everything else, the whole bunch, you dump it together in the other patient IDs, which is actually multi-valued. So we can do 1, 2, 3, 4, 5, and then the values, multi-values are actually separated by the backslash. So 1, 2, 3, 4, 5, backslash, 6, 7, 8, net, backslash, and so on. So we map it into the primary patient ID and then other patient IDs. So you can maintain it. People don't necessarily know about it. Is it true that you can put all the other ones in there? Assuming again your worklist provides it, but most of them do. So you can carry them around and you can put it then eventually even in the DICOM header. Okay. One more probably, right? You have one more question?
Yeah, I think we have time for one more. Can you please elaborate what happens when an MWL SCP receives an HL7 order? Does the MWL SCP create a DICOM information object definition for the modality to utilize?
Okay, can you repeat that?
Sure. We can actually post that in the chat for you to read as well. But can you please elaborate what happens when an MWL SCP receives an HL7 order? Does the MWL SCP create a DICOM information object definition for the modality to use?
Oh, so now the modality worklist provider does not really create a image object, right? So basically what happens, if you look at the mapping, okay, that's what happens. So if you look at the mapping, so it takes the instance 7 on the left, okay? So it tells you all of the attributes on the left. And basically on the right, there's a DICOM modality worklist query. So the DICOM modality worklist query has a list of all the attributes, patient name, patient ID, patient sex, procedure code, or whatever. So all of the attributes are responses called a query response to my query. So I have this list of information at my modality, patient demographic information, ID, birthday, sex, and so on. Scheduling information like 9 o'clock and information about the procedure. And then this list is copied locally in the modality. Most of the time we're going, for example, in the terminal database. And then that information in addition to other information from the modality, for example, the operator, and if it's a CT scanner, the KV, the MES, the procedure, procedure description and the table height and the slice thickness and so on, all of that, together with that information from the HL7 order that was mapped into the modality release provider response, all of it together becomes the DICOM header that is stuck in front of the pixel data, and that is then the DICOM object. I hope that's clear. Okay.
Awesome. Well, thank you, sir. And thank you for everyone who was able to attend today's IIP Tips and Tricks session. If you did open up today's webinar in the Zoom URL, you should be redirected to our post-webinar survey. If you're not, don't stress about it. You will be receiving that link tomorrow in an email, probably around 11 a.m. Eastern Standard Time. Should you have any additional questions, don't hesitate to reach out to our staff. We're always available at education@siim.org. And we hope that you have a safe and happy holiday season and look forward to seeing everyone back here in January for the third and final session in the IIP Tips and Tricks series.
Okay, thank you, appreciate it.
Thanks, Herman. Stay safe, everyone, and we'll talk to you next month.
Okay, sounds good.